Hey everyone. So we're in the Khan Academy class, the Algebra 1 class today. So somebody requested in the comments, it was the first comment request, which I thought was pretty cool, to do the Unit 14 test for Algebra 1. So what I'm going to do is, so with Algebra 1, this is one of the last units, as you can see. It's the last unit where you can actually get mastery points. There's a ton of information covered in it on quadratic functions and equations, and a lot of it's actually kind of more at the Algebra 2 level. So this is useful for Algebra 2. It's higher level Algebra 1, useful for really any level starting at like the higher level Algebra 1 and even after that. So I think it's very useful for even Algebra 2 students. So hopefully doing this unit test helps. I'm going to open it up. And what you'll notice is that there's a ton of quizzes that build into the test. So if you're struggling with any of the specific types of questions, just go into the smaller question sets. And I think there's 6 quizzes. You can see quiz 1, 2, 3. So you see a ton of question sets, 4 quizzes, 5, and 6. So all of the questions for the unit test kind of feed from those 6 quizzes. There's a ton of different stuff. So I'm going to do my best to try to cover like a broad set of topics with quadratic functions. And hopefully this helps. All right, so let's check it out. All right, it's 25 questions. This will probably end up being multiple videos. So let's see. All right. Okay. So nice fun one right off the bat. It says solve for x, enter solutions from least. It's a quadratic function. So I know that if I were to graph this, it would look like a U shape. I don't exactly, this is just at a very basic level. If I have a graph kind of with a y-axis going up and down and an x-axis left and right, this graph I know would be a quadratic form. It'd be a U shape. So it would go down and it would dip and have a minimum, and then we go up to infinity on the left side and the right side. I know it's facing up because the leading term is positive at 3x squared. So what I'm going to do is it's asking for the solutions. So with a quadratic function like this, if you look at the graph, these 2 points here, let me point them out in black. These are the solutions to the equation, here and here. So when you talk about a solution of a quadratic equation, you can think of it as the x-intercepts. It's the 2 points, or maybe the 1 point, and sometimes there are no points where the function crosses the x-axis. So those are known as the solutions. So my thought is there's going to be 2 of them, and it says put in here the lesser x and the greater x. So we're going to get 2 solutions, and the lower one will go first. Okay. So for this question, first time I tried it, I did not realize that you can pull out a common factor. So if you can, that can be a very useful strategy. It's easier to factor things when the leading term is 1x squared or just x squared. So what I'm going to do is pull a 3 out of all of this. If I pull a 3 out of everything, pull a 3 out of 3x squared, you're left with just x squared. If you pull a 3 out of negative 33x, you're left with negative 11x. And if you pull a 3 out of 54, you're left with 18, I believe. Yes, 18. So we'll say plus 18. So this makes the quadratic much easier to factor, because now what I can look for is I need to find 2 numbers that multiply to positive 18. So the numbers need to multiply to 18. Let me change the color. Multiply to 18 and add to negative 11. So this is kind of the tricky part, is figuring out what are those 2 numbers, multiply to multiply to positive 18 and add to negative 11. So the numbers I like here are 9 and 2, and I think both should be negative. Negative 9 times negative 2 is 18, and negative 9 plus negative 2 is negative 11. So I can factor this as 3 times. What I'm doing is I'm rewriting everything in parentheses, and the way I can write it is using the numbers 9 and 2. I can say it's x minus 9 times x minus 2. And if I were to multiply this out, I could check it, but the negative 9 times the negative 2 are going to multiply to the positive 18. So my constant will be plus 18. And I'm going to have a negative 9 times this x. That's negative 9x, but I'm also going to have a negative 2 times x. So I have a negative 9x and a negative 2x. That's where you get the negative 11x. And then x times x is x squared. So the idea is that you're just rewriting the green as the orange. I've factored it now. But what this lets me do is figure out what the solutions are. So the solutions, in my drawing here, The solutions of a quadratic. So if I have a positive quadratic, the solutions are the x-intercepts. There are often two solutions. Here, there's going to be two solutions. And you can see where they are in this factored form, because what's going to happen is if I want the function to equal 0, when f of x equals 0, if I want y to equal 0, remember f of x is y. When y equals 0, those are my solutions, here and here, or when y equals 0. So what I'm going to do is I'm going to set the function equal to 0, and now I can solve this a little easier because there's two numbers I can see in this form. If I plug in the number, sorry, it's a little ugly. If I plug in the number 9, that will make the whole expression 0. And if I plug in the number 2, that will make the whole expression 0. So the intercepts in this case are 2 and 9, and they're both positive. So they're the numbers that I could put in for x that'll make the whole thing equal 0. So it's going to be 2 and 9. So the lesser one is 2, and the greater one is 9. All right, very nice. All right. Okay. So this says, which function has a greater minimum? So it looks like f of x is written up at the top. So f of x is written. This is the function f of x. I don't know what it looks like, but you could graph it. And below I have g of x. So it's two different functions, and it says which one has a greater minimum. It's kind of a weird question, but greater minimum. So on the blue one, it's simple to see the minimum is right here. It's the lowest point. So I'd say the minimum is at -3. So what I'm going to do is I'm going to check on the other function. Is the minimum higher or lower than that? So this function, f of x, it's going to be a positive quadratic function. The leading term here is my x is positive, 5 is positive, everything's positive. So it's going to be an upward U shape. So the minimum is going to be wherever the vertex is, wherever the graph is split, wherever the line of symmetry down the middle is. So in this is in vertex form, this quadratic here. So the vertex of a quadratic in vertex form, so this is in vertex form here. Let me write that real quick. So y equals a times x minus h squared plus k. This is vertex form. And you can see in the videos, to get more in depth on vertex form. But when you have vertex form, what's going to happen is that the y value is going to be k, and the x value is going to be h. This is of the vertex. So the vertex. If you think about it in this form, the vertex will be hk. It will be the points hk. So for us, h is 4 because we're subtracting 4. So the vertex is at 4, and then k is at -3. So the vertex is 4, -3 on the graph. So it's going to be 4, -3. So I don't know what the intercepts are exactly, but it'll be something like that where it's upward facing. And it looks like these two functions have the same minimum of -3. So I think I'm going to select the option where they have the same minimum. F and G share the same minimum. All right, very nice. This question says, consider the equation. X squared plus 10x plus 22 equals 13. Rewrite the equation by completing the square. Your equation should look like x plus c squared or equals d, or x minus c squared equals d. Okay, cool. So what we're going to do is we're going to use completing the square as a method to solve this quadratic equation. So what completing the square does is it wants to take this chunk here and isolate it. So let's get the constants all on the other side. So I have x squared plus 10x. I'm going to leave a space here, and we'll see why. This equals, so I had 13. I subtracted 22 from both sides. So 13 minus 22 is -9. So right now, this is my equation rewritten. All I've done is I've subtracted 22 from both sides. This gives me, on the left side, x squared plus 10x. On the right side, -9. So what I'm going to do to complete the square is, so the method is to take the middle term b. You take half of that and square it. That's what you're going to add to both sides. So half of 10 is 5. And if I square that, that's going to be 25. So I'm going to add 25 to both sides. I need to add it to both sides in order to keep the equation balanced, right? Because you can't just mess with an equation. You can't just randomly add things, but you can do the same thing to both sides. That keeps everything in balance. So what this does is on the left side, I can now factor this very simply. It's going to be x plus 5 squared. So to see that, to understand that a little better, another way to write that is x plus 5. And if you are squaring something, that means you multiply it by itself. So x plus 5 squared is the same as x plus 5 times x plus 5. If you were to multiply these together, FOIL it, first outside, inside, last, you get x squared plus 5x plus 5x. That would give you 10x. And then the 5 times 5 would give you 25. So what we're doing with completing the square, you're taking one side and you're just making it easy to factor in this form of x plus or minus something squared. So in this case, we've gotten it to x plus 5 squared. So it's always going to be half of the b term, half of your middle term. And on the right side, this equals negative 9 plus 25. So that is 16, positive 16. So I think that's a good form because it looks like the first one here, x plus c squared equals d. So we'll say x plus 5. X plus 5, and we will square it. Equals 16. So I think I like that. And then what are the solutions? So in order to solve this, we could take the square root of both sides. So that's going to give us x plus 5 on the left side. And the square root of 16, there's two square roots of 16, 4 and negative 4. So I can say 4, or I can say x plus 5 is negative 4. It's going to give us two answers. But it looks like with the format of the answer, like if you look at the multiple choice, it's giving it with plus or minus 4. So it's going to be either A or B, because when we took the square root of 16, we'll say plus or minus 4. So x is going to equal, if you solve for x, you'd have to subtract 5 from both sides. So it's going to be negative 5 plus or minus 4. So x is negative 5 plus or minus 4. So I like the answer choice B. It's a negative 5 plus or minus 4. So hopefully that all looks good. It likes those answers. So this says the function g models the number of mosquitoes in millions of mosquitoes in a certain area as a function of rainfall in that area. So from this graph, it looks like the amount of mosquitoes, as it rains more, the amount of mosquitoes goes up until it gets to 2 centimeters. That's where it's going to max out. And then if it rains more, there's actually fewer mosquitoes. And if it rains 4 centimeters, you can expect no mosquitoes, at least based on this function, based on this model. So it's a multiple choice. So let's choose all answers that apply. So we just kind of talked about what it means. So let's read them. More rainfall relates to more mosquitoes. That's true, as long as the rainfall is less than 2. Yeah, that's right. So from 0 to 2, more rainfall means more mosquitoes. More rainfall relates to more mosquitoes as long as rainfall is more than 2. That is not true. So B is the opposite of what we said. Once you get over 2 centimeters of rain, there actually are fewer mosquitoes because the graph is going down, 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 down. And eventually it gets down to 0 once you get to 4 centimeters. So I don't like B. C says when there is no rainfall, there are about 1 million mosquitoes. So what it's saying is that when the rainfall is 0, we should see 1 million mosquitoes. So that point would be right here. That's not on the graph. When there's no rainfall, there are no mosquitoes. So I don't like C. And D says when there's no rainfall, there's about 2 million mosquitoes. So I don't like that. When there's no rainfall, the graph is showing me that there are 0 mosquitoes. So I think A is my only correct answer here. All right, ready. So this question says, Chanel has 100 meters of fencing to build a rectangular garden. Okay. The garden's area in square meters as a function of the garden's width is modeled by. So the area as a function of width is negative x minus 25 squared plus 625. And it's asking what is the maximum possible area. So this is a quadratic function, so it's going to be a U shape. The x is going to be negative because of that negative sign in the front. So we're going to get a negative quadratic function. So that means an upside down U shape. So what that tells me, and why I'm saying that, is it's asking what's the maximum area. This function is showing the area. The area is going to go up, 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 and then it's going to peak here at the vertex, and then it's going to go down, down, down. So wherever the middle of this function is, that will correspond to the maximum area of the garden. So where's the maximum area? It's at the middle of the graph. It's at the vertex. Where's the vertex? This is in vertex form. So we saw this earlier. So the vertex is HK in vertex form. So the K is just the number at the end. So the K is 625. And that is actually going to be our answer. 625 is the Y value. The X value is 25. But what that's saying is that when X is 25, when the width is 25, the area will be 625 square meters. So the maximum area possible should be 625 right at the vertex. Very nice.